In this video, we're going to focus on solving two-step equations, and this time we're going to focus on types 3 and 4. So these are two-step equations that contain division in place of that multiplication. So today we're going to be focusing on two-step equations that look like the following. And hopefully you're noticing that these two types of equations are pretty similar. First, I hope you're noticing that they both contain division within this fraction symbol. So both of these contain division, and then both of these, depending on how you look at it, if you use keep, change, that's fine. If you leave it as subtraction, that's fine. But they each contain division and then an addition subtraction going on there. So we're going to focus on what we do when we have division inside of two-step equations. Now what I do hope you are also noticing is that these are slightly different. If you look over here at the equation on the left-hand side, you're going to notice that we have the x and the 4 contained in the fraction, and the plus negative 5 is by itself not contained in the fraction piece. And if you look over here at this example on the right, the x minus 5 is all contained up here in the numerator. So it's actually a part of the fraction. That negative 5 is within the fraction. So slight differences between these two. One thing that I want you to notice up here is that if you have something like x plus negative 5 together in the top of a fraction, you're always going to put parentheses around it. There are implied parentheses up there grouping those together in the top. So just keep that in mind when we do our order of operations backwards, that there are parentheses up here in the numerator of this fraction. So in order to solve these problems, we're going to take the exact same approach that we took yesterday. What we're going to do is we're going to list out the order of operations here on the left-hand side, and then we're going to undo those order of operations in reverse. So here, if I look at my equation, what I'm noticing is that I have division and addition here. And so order of operations, if I think about my PEMDAS, I know that if my options are division or addition, that division comes first. So I'm going to write down divide by 5. That's my first in the order of operations. And then second comes the addition of a positive 14. So what I'm going to do here is, now that I know my order of operations, I am going to undo these order of operations backwards. So we list out our order of operations, and then we undo them in reverse in order to solve the equation that we are trying to solve. So if we start here with this plus 14, in order to undo a plus 14, we need to subtract 14 from each side. So we have 14 and then a negative 14 together, so that becomes 0. So we're left with x over 5 is equal to, we have negative 19, and then we have another negative 14. And so if we subtract those two, or you can even use keep, change here if you want, negative 19 plus negative 14 leaves us with negative 33. And then from here we move up 1. Now we want to undo the division of 5. In order to undo a division, we need to multiply both sides by 5. So multiplying both sides by 5 will leave us with just x on the left-hand side, and then negative 33 times 5 leaves us with negative 165. So now we have found our x value that if we were to put it back up here into this original equation, the original equation would become true. So now let's look at this second example here. And what I notice is that this one looks a little bit different. Because this x and this subtraction of 5 are up in the numerator, I actually have to group them together using parentheses. So I always want you to put parentheses around the top of a fraction if there is an operation up there. And then I'm going to utilize keep, change here to help me out. So in order to solve this equation, I need to write out my order of operations first, because I'm going to undo my order of operations in reverse. So I know in my order of operations that my parentheses always come first. And because of that, in my order of operations, what's going on in the numerator of this fraction, which is inside of parentheses, is actually going to occur first in the order of operations. So here you can either write down subtract 5, or you can write plus a negative 5, whatever you would like to write down is fine with me because we're going to undo them just the same. So our parentheses come first, and then our division of 4 comes second. And then what we're going to do is we are going to undo the order of operations in reverse. So we're going to go backwards here. And in order to undo this division of 4, we're going to multiply by 4 on each side. So we start off, we multiply by 4, those cancel out, we multiply by 4, and we're left with x plus -5 is equal to 48. And then from here we move up and we need to undo this addition of -5. And I want to make this become 0 when I add it together with another number. So we're going to add 5 here to each side. So we end up with x is equal to 53. So I found my value for x, where if I put it back into the original equation, it will make that original equation true. So example 3 here, I notice that I have two operations taking place. I have a division right here, and I have an addition of 9 right here. So order of operations, if I write them out using my PEMDAS, I know that division of -2 is going to come first, and then the addition of 9 is going to come second. So in order to solve this equation, I need to undo my order of operations in reverse. So in order to do that, I need to undo a +9, so I'm going to subtract 9 from each side. So these become 0, and I'm left with x over -2 is equal to, well, I have 3, and then I'm going to use keep change here, 3 plus a -9, which is a -6. So now I've undone that addition of 9, so I'm going to move up one and undo the division of -2. In order to undo division, I need to multiply by a -2. So I'm going to multiply both sides by a -2. And then here, these cancel out, so I'm left with x is equal to -6 times -2 is a positive 12. So here I found the x value, or if I plug it back in here, I will make the equation true. Two more examples to go. So here we notice that we have an operation up in the numerator of our fraction. So we know that we need to add parentheses into this problem before we start identifying our order of operations. And then if I use my PEMDAS, I know that parentheses comes first. So in this particular equation on the left-hand side, if I were to follow the order of operations, I would add 4 first because it's contained inside of parentheses, and then I would divide by a -3. So from here, I then need to undo my order of operations in reverse. So I'm going to start by undoing a division of -3, and in order to do that, I need to multiply both sides by a -3. Those, as a result, cancel out, and I'm left with x plus 4 is equal to a -18. I then need to undo this +4 here, so I'm going to subtract 4 from each side. So I subtract 4, those become 0, subtract 4. So I have x is equal to, I have -18 minus 4 more, or -18 plus -4, which leaves me with -22. And -22 is the value, or if I were to put it back in this original equation, it would make the original equation true. And last example here, hopefully you're getting the hang of this. Again, we're going to list out our order of operations, and just to be safe, I'm going to go through and utilize my keep change so I don't make any errors. So I use order of operations. Well, I have no parentheses. I don't have any multiplication, but I do see that I have a division here. So my division of 4 would come first in the order of operations, and then adding a -5 would come second in the order of operations. So I undo my order of operations in reverse. So in order to undo this plus -5 here, I need to simply add 5 to each side. Doing so, -5 plus 5 will cause this to be 0. So then I add 5 to the right, so I have x over 4 is equal to 15. I then need to undo a division of 4 by multiplying by 4. So those 4's cancel out, and I need to multiply the other side by 4. And then I get x is equal to 60. So there is my value for x, that if I were to put it back into this original equation, it would make the original equation true.